Welcome to the Prompt Index, the podcast where we unpack the latest AI research and translate it into something you can actually use. Today, we dive into a study that sits at the intersection of IoT security and large language models, a topic that's increasingly relevant as billions of devices come online. So, what problem are the authors tackling? LLMs are being deployed in network intrusion detection systems to analyze attack patterns and suggest mitigations. But this creates a new risk surface. If the knowledge base that guides the LLM's reasoning, the retrieval augmented generation, or RAG component, gets poisoned, the entire defense can wobble. The paper asks, how robust is an LLM-driven IoT threat framework when its RAG data is subtly manipulated? Here's how they approach it. First, they build an attack description dataset covering 18 attack types using prompt engineering. They then enact a transfer learning-based data poisoning attack on the RAG system. A BERT model is fine-tuned as a surrogate target to learn how paraphrase variants map to labels. Using TextFooler, they generate word-level perturbations that preserve meaning and grammatical structure under POS constraints. These adversarial descriptions replace the originals in the RAG knowledge base. The target model is ChatGPT-5 Thinking, tested in a black box setting, with a suite of judge LLMs and human evaluators scoring the results on attack analysis, mitigation quality, technical depth, and clarity. On the datasets EdgeUOT set and Seif 2023, they combine a random forest detector with RAG to retrieve attack descriptions and device specs, then prompt the LLM for analysis and device-aware mitigations. The results show that small, meaning-preserving perturbations can degrade the link between observed traffic features and attack behavior, making mitigations less practical for resource-constrained devices. For example, pre-attack responses scored perfectly in their pilot sample, while post-attack responses showed measurable degradation in threat understanding and mitigation quality. The evaluation also highlights how judge LLMs and human experts perceive the differences in depth and practicality after poisoning. Limitations are acknowledged, attacks remained partial in effect, and the study centers on 2 IoT datasets and a surrogate target model. Future work points to coordinated multi-signal attacks, blending RAG and traffic perturbations, plus defense strategies to harden retrieval-grounded reasoning. The core takeaway: even state-of-the-art LLM-based IoT defenses are vulnerable to targeted RAG poisoning, underscoring the need for robust grounding, prompt safeguards, and continual adversarial testing as we deploy AI at scale in real networks. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free resources at the Prompt Index. You'll find the link in the description below. Until next time.